there. Imagine you're on a roller coaster speeding through a loop or spinning a ball tied to a string in a circle. Have you ever wondered what keeps these objects moving in a circular path instead of flying away? That's where centripetal acceleration comes in. Let's break it down in a way that's easy to understand. Step-by-step explanation of the two formulas. The first formula for centripetal acceleration is acceleration equals the square of the velocity divided by the radius, written as a sub c equals v squared divided by r. This formula tells us how much acceleration is needed to keep an object moving in a circular path. Let's break it into parts. A sub c, this represents centripetal acceleration, which is the force pulling the object toward the center of the circle. V, this is the speed of the object as it moves along the circular path. R, this is the radius of the circle, meaning the distance between the object and the center of the circle. Key idea: the faster the object moves, or the tighter the circle, meaning a smaller radius, the more centripetal acceleration is needed to keep it moving in a circular path. The second formula for centripetal acceleration is acceleration equals negative omega squared times the radius, written as a sub c equals negative omega squared times r. This version uses angular velocity, which is another way to describe how fast something spins. Here's what the terms mean. Omega, this is the angular velocity, or how quickly an object rotates or spins around the circle. R, this is the radius of the circle, just like in the first formula. Key idea: this formula is most useful when you're dealing with spinning objects like a merry-go-round or a ceiling fan. Real-life example: spinning a ball on a string. Let's say you're twirling a ball tied to a string in a circle. The radius of the circle is 2 meters, and the ball is moving at a speed of 4 meters per second. Using the first formula, step 1, start with the formula, a sub c equals v squared divided by r. Step 2, plug in the values. The velocity is 4 meters per second, and the radius is 2 meters. So it becomes a sub c equals 4 squared divided by 2. Step 3, solve the equation. 4 squared is 16, and 16 divided by 2 is 8. 2 is 8. So the centripetal acceleration is 8 meters per second squared. Using the second formula, if the angular velocity of the ball is 2 radians per second, we can use the second formula. Step 1, start with the formula. A sub c equals negative omega squared times r. Step 2, plug in the values. The angular velocity is 2 radians per second, and the radius is 2 meters. So it becomes a sub c equals negative 2 squared times 2. Step 3, solve the equation. 2 squared is 4, and 4 times 2, 2 is 8. Add the negative sign, and you get negative 8 meters per second squared. The negative sign shows that the acceleration points inward, toward the center of the circle. Both formulas give the same magnitude of 8 meters per second squared. Exercise time. Your turn. Here's a challenge for you. A car is driving around a circular track with a radius of 10 meters. The car's speed is 5 meters per second. What is its centripetal acceleration? Bonus: if the angular velocity of the car is 0.5 radians per second, use the second formula to calculate the centripetal acceleration. Write your solution, show your steps, and post your solution in the comments. Let's see how you did. Wrapping it up, now you know how to calculate centripetal acceleration using 2 simple formulas. Whether it's a car racing on a circular track, a ball on a string, or even a planet orbiting a star, these concepts are everywhere in the real world. Stay curious, keep learning, and remember, physics helps us understand the forces that keep the world and beyond in motion. Did you find this explanation helpful? Let me know in the comments. Don't forget to like, share, and subscribe for more simple and fun explanations of science topics. Until next time, keep spinning those ideas.